understand really what's behind the blockchain. So what are the pros and cons of the different ledgers? With traditional databases, you can be much more efficient. With the blockchain, you have multiple computers doing the same calculations, including the same information, communicating between them. So it's a very inefficient ledger. Blockchains are not for everything. This is the key of the blockchain. Proof of work is a consensus algorithm. It's a way to make sure that all computers in the network have the same version of the ledger, have the same truth. So cryptography comes from the Greek cryptos, which means hidden or secret, and graphy, which means to write or text. So basically it's like the secret text or the hidden text. There's two main types of cryptography. The most simple one is symmetric encryption, which means that one single key can be used to encrypt the information and to decrypt it. In Bitcoin, we have something that is called asymmetric encryption or private public key encryption, which means that you need two different keys to encrypt the information with your private key. Your public key, as its name says, is public, and people can decrypt that information, so they can understand what you encrypted, but they cannot know your private key. From your private key, you can get a public key, but from the public key, you can never go back. What kind of data can we hash? Anything. There's three characteristics of hashes. The first one is that they are unique. The second characteristic is that they are asymmetrical. And the other thing is that hashes are patternless. So how does it look in Bitcoin? You have different transactions. Each transaction is going to be hashed. And then you start grouping those hashes. And then you have this Merkle root. And what happens with this Merkle root? This Merkle root goes to the block. So mining. You have different computers around the world trying to include the next block. If you want to send a transaction, you include it in the mempool. Miners take transactions from the mempool and they create a block. And then they start trying to make that block valid to be included in the block. They do it by changing the nonce. All this information will give you a hash. Let's say you start with nonce 0. This hash is different than if you have nonce 1, and it's different than if you have nonce 2. So what miners are doing all the time is just changing these nonce to get a hash that is valid. A valid hash is a hash that starts with a number of zeros. Consensus, what it means is that we all need to agree that the next block is valid. There are other consensus algorithms besides proof of work. Ethereum is switching to something called proof of stake. So how it works is that the different participants in the network can decide, okay, I'm gonna put some Ethereum at stake. The probability that you are the validator is basically the amount that you stake divided by the whole stake of the network. Delegated proof of stake is similar, but the difference is that you give your voting power to some nodes. You have proof of authority, which is mainly for the permission ledgers. So with regards to all these consensus algorithms, there's a blockchain trilemma, which is basically that you can have two out of these three properties. So you can have security, decentralization, or scalability, but you cannot have the three of them.